Now, I'm going to show you how to simulate simple two-gene regulatory network using Unity. So let me Google Unity, click download Unity. I'm going to download Unity Hub. I agree, install, set up Unity to begin creating. So if you click this official releases, you want to select the latest version. So let me click this download. So in case I want to deploy my Unity application to Android devices or iPhones, I need to select these ones. So click Android build, iOS, and WebGL if you want to publish your Unity application to web. So now I say done. The downloading starts. I'm going to open Unity. I click new and project name and click create project. So hold on for a minute. Now click game object, 3D object, and let's click a sphere. So we have a sphere, and let us change the name of this to cell. Now you see that the name is changed here as well. And create a C# script for this cell. For that, let's click add component, new script, and let's call that script a cell script, and click create and add. Now you see that we have this cell script. So let me open this by double clicking it, and Visual Studio opens. By the way, in case you don't have Visual Studio installed on your computer, a default Unity editor will open. Now we have a Visual Studio opened. So here we have the code that I have written for this simulation. I have this X variable, which has a type float, single precision number. When I say single precision, it means that this number is represented by 32 bits. And we have this Y for Y protein concentration in micromolar. And PXY is production perimeter, PY degradation perimeter. R is red color intensity representing Y protein concentration. And the value goes from 0 to 1. So in this simulation, we want to represent Y protein concentration using this red color intensity. But the range goes from 0 to 1, so we need to do some sort of mapping. And this Ymax is maximum Y protein concentration that we assume it is used for the mapping. So this start function or method is used for initialization. Here we have these two parameter values, PXY and PY. X, we assume that it is 10 micromolar. And note that once we initialize it, it will be used throughout the simulation unless you change the value. Here we initialize Y as 0. However, this Y value will be changed many times throughout the simulation. And this Ymax here is 2 times this value, which is a steady state. So this is a formula that we can use to find the steady state given PXY, PY, and constant X values. We are assuming that the maximum Y protein concentration is twice the steady state. So when Unity application runs, many frames are displayed per second, and fixed update is called once per frame. So this method is called once per frame. 0.02 seconds or 50 calls per second is a default time between calls. We will have this fixed update executed 50 times per second. And in case you want to change this time interval, 0.02, let's say to 0.5, you can have this expression, time dot fix the delta time. If you change this, fixed update is executed at different frequency. Now you have the difference equation here. So using this constant X and Y, which comes from here in the beginning, but later, once we have a new Y value, that value will be used for the next update. Here we compute R, red intensity. We are normalizing this Y protein concentration with maximum concentration, and this line is changing the color intensity of the cell. These two lines are used for debugging. This line will display Y value in the Unity console window, And this line will display our value in the Unity console window. Before I run the simulation, I need to do one more thing. So I go to Assets, Create, and Materials. I need to give a name for this new material. Say this is a cell material. I want to apply this material to this cell. So I drag and dropped it onto the cell. Now let us save the code and let's run the code. You see that the color intensity changing. And if you go to this console window, you can see that the white protein levels are approaching a steady state, which is around 155 in this case. Let me stop this and let's go back to the code. And instead of having 0.5, we want to have a 0.05. And let's see what happens. You can run it. Now you see that actually the color is changing faster.